Imagine discovering a tomb in ancient Egypt, sealed in darkness for more than 3,000 years. Among gold and priceless relics, archaeologists come across a plain, unremarkable jar. When they finally open it, they find a thick golden liquid that is still completely perfectly edible. That liquid is honey. It is the only natural food on Earth that virtually never spoils. But how does such a tiny insect produce something capable of outlasting entire empires? Today we're taking a simple jar of honey sitting in your kitchen pantry and revealing the astonishing, almost magical chemistry behind its creation. The story of honey doesn't truly start with bees. It begins with flowers. To attract pollinators, flowers produce nectar, a sweet, watery fluid. This is where the hero enters, the female worker bee. She is a forager. Every day she visits up to 1,500 flowers. To produce just 1 pound of honey, a colony must collect nectar from around 2 million flowers, traveling a total distance equal to circling the Earth 3 times. When a forager lands on a blossom, she uses her long tube-like tongue, called a proboscis, to draw up the nectar. But she doesn't digest it. Instead, she stores it in a special internal chamber known as the honey stomach. This is where real transformation begins. Inside the bee's honey stomach, the nectar mixes with an enzyme called invertase. This enzyme immediately starts breaking down complex plant sugars into simpler ones, glucose and fructose. When her honey stomach is full, the forager returns to the darkness of the hive. But she doesn't simply deposit the nectar into a honeycomb. Instead, she passes it mouth to mouth to a younger processor bee. This processor bee works the nectar further, chewing it for around 30 minutes and adding more enzymes from her own glands. This process does more than sweeten it. It produces trace amounts of gluconic acid and hydrogen peroxide, creating an environment that is highly resistant to bacteria. It is no longer raw nectar, but it is not honey yet. At this point, the mixture is still too watery. If left like this, it would ferment and spoil. So the bees spread it into the perfectly shaped hexagonal wax cells of the honeycomb. Then thousands of bees begin a synchronized effort. They fan their wings rapidly, generating a steady flow of warm air throughout the hive. This constant ventilation evaporates the excess water from the nectar. The moisture content drops dramatically from about 80% down to under 18%. Slowly, the liquid thickens into something dense, sticky, and remarkably stable. Finally, to preserve it, the bees seal each cell with an airtight layer of beeswax, locking it away for long-term storage through harsh seasons. The next time you stir honey into tea or drizzle it over breakfast, take a brief pause. You are looking at the collective labor of thousands of bees. A single worker bee produces only about 1/12 of a teaspoon of honey in her entire lifetime. That spoonful required countless flights and millions of flower visits. It is a quiet masterpiece of nature, chemistry, and cooperation. Thank you for exploring the surprising history behind ordinary wonders with us today.